Ladies and gentlemen, I want us to have a look at this question. Now, the question is, solve the following simultaneous logarithmic equations. We have the logarithm of xy squared to base 2 equals to 0, and also the logarithm of x squared y to base 2 equals to 3. Now, how do we solve these simultaneous logarithmic equations? Now, remember this one is in logarithmic notation. We can write it in index notation, and also we write this second equation in index notation because they are all in logarithmic notation. Now, from equation 1, because this is our first equation, we can write it in index notation so that we have 2, this 2 that is here, raised to 0, which is this one, equals to xy squared. And in this case, we shall have, that is xy squared, that is xy squared equals to 2 raised to 0. That is a number raised to 0. Any number raised to 0 is always 1. And therefore, 2 raised to 0 is 1. This is our first equation. Now, from equation 2, because this is the second equation, this is the second logarithmic equation, if we write it in index notation, we shall have 2 raised to 3, that is 2 raised to 3, equals to x squared y, that is x squared y. And this implies that we shall have x squared y equals to 2 raised to 3 is 8, and therefore this is our second equation. Now, since we have two equations, we have obtained two equations from these two simultaneous logarithmic equations, then we shall proceed to solve for the value of x and for the value of y. Now, from equation 1, we can make x the subject of the formula. We can say from equation 1, that is from this equation, that is xy squared equals to 1, we can make x the subject so that we have x equals to 1 over y squared. That is from this first equation. We can divide by y squared on both sides so that we have x equals to 1 over y squared. Now, since this is what we have obtained from equation 1, we can substitute this in our equation 2. Now, from equation 2, we have x squared. And in this case, if we substitute x, that is in our equation 2, with 1 over y squared, we shall have, that is 1 over y squared, then we close the bracket, then we square it, then we have this y, that is times y, equals to 8. Now, in this case, we shall have, that is 1 over y squared, close the bracket, raised to 2, is 1 over y raised to 4. Then close the bracket, times y equals to 8. Now, 1 over y raised to 4 times y, then is just the same as 1 over y cubed. This is the same as 1 over y cubed. Then equals to 8, because we simplify this with this and we obtain y to the power of 3. Now, since we have 1 over y cubed equals to 8, then 1 over y cubed can be written as y raised to negative 3, which is just the same as 8. And also, we can have y raised to negative 3 equals to 8 can be written as 2 raised to 3. Now, from there, we can have y raised to, that is y raised to negative 3 as 1 over y, then we close the bracket, raised to 3, then equals to 2 raised to 3. Now, since the powers are the same, then we equate the bases. The base here is 1 over y, and the base here is 2. Since the powers are the same, and there is an equal sign in between, that means we equate the bases. And therefore, in this case, we shall have 1 over y equals to 2. And in this case, I can multiply by y on both sides. And if I multiply by y on both sides, I shall have 1 equals to 2y. And if I divide by 2 on both sides, this implies that I shall have y equals to a half, because I have to divide by 2 on both sides. And since I have obtained the value of y as a half, and our x was 1 over y squared, that is from equation 1. Our x is 1 over y squared. And therefore, our x will be 1 over, instead of y, we shall have a half. And therefore, in this case, we shall have a half squared. Now, having x equals to 1 over half squared, a half squared is just a quarter. That is a half times a half, which is a quarter, and therefore 1 divided by, that is 1 divided by, a half squared is a quarter, and therefore in that case, I will have 1 times the reciprocal of a quarter, which is 4 over 1. And in this case, I will obtain my x as 4.